Hello, fellow math people. This is Mr. Kingsbury coming to you live. Well, you're probably watching the video, so I'm probably not live anymore. But right now, I'm live while I'm recording it. Anyway, I just thought I'd jot some more notes down here. So yeah, of course, this is for the Algebra 2 class. Our unit is quadratics, and today we are going to talk about something called complex numbers. And actually, they're operations. So our essential question is, how do I add, subtract, and multiply complex numbers? Well, I'm going to tell you, before you can do any of those things, you need to know what is a complex number. What is a complex number? Good question. It should take the form A plus BI, where A and B are real numbers. Technically, all numbers can be written this way. Most of the numbers in fact, all of the numbers you've worked with for the entirety of your life up until this point have had a 0 for the B. So this part was gone and you just kind of focused on the A part. But now we're going to throw this piece in, which begs the next question, what is this I thing? Well, I is actually the square root of -1. And there's actually I'm going to rewrite this, a whole thing. Let me just show you. So I is the square root of -1, which means I squared would be straight up -1. Interestingly enough, I cubed is the negative square root of -1. And that's I cubed. And I to the fourth would be just 1. You don't really need to know that, but it kind of goes into pattern, and I can prove that to you if you want. So why do we have I? Well, it turns out that when you take the square root of something, like say the square root of 16, you have two values, the positive 1 and the -1. All right, but when you take the square root of something, you're finding what you multiply by itself to get that number. So 4 times 4 is 16, -4 times -4 is 16. And that works for any positive number. But when you try and take the square root of a negative number, that presents a problem. And actually, there is a series of rules that go with square roots that allow us to transform this a little bit. I can rewrite a single number as the product of two numbers. So I'm taking the square root of a single number. I can rewrite it as the product of two numbers, or the square root of the product of two numbers. So it turned out that all of these negative numbers can be rewritten as the positive version times -1. And then you can actually take the square root of both sides. And what that left mathematicians with was the idea that every negative number had a square root somewhere, somehow. It's just we couldn't find it. That the only number really we don't know the actual square root to, or that we haven't defined it, haven't defined the square root of, is -1. So someone said, well, why don't we define the square root of -1 as I? So that's what we did. That's where I comes from. I stands for imaginary. And it's not like your imaginary friend imaginary. It's imaginary in the sense that it does not exist in the world. It can't be quantified or measured or something like that. So how does this help us? Well, since we have these i's, if we can remember that I squared equals -1, I'll show you how to do the adding, subtracting, multiplying, etc. And then at the end, I will mention how this fits into the whole big scheme of things. So let's just do an example where we're adding. Let's say we have 5 plus 6i plus 3 minus 2i. Why not? Just like polynomials, all I have to do is add the two parts without an I and add the two parts with an I, and then I'll add those two pieces. So 5 plus 3 is 8, and 6i plus -2i is 4i. So that's all there is to it. Pretty straightforward. Let me do another one with subtraction. What if I did the same thing? 5 plus 6i, and I subtracted 3 minus 2i. Again, all I have to do is put this stuff together. That's the same. So I would do 5 minus 3, and I would do 6i minus -2i, and we'll add those pieces. 5 minus 3 is 2. 6i minus negative 2i. Oh, look, two negatives. They become positives. So this is 6i plus 2i, which is 8i. So, no big deal. And this applies to no matter, how many there are, how many of these things you're adding. Last example, and I'll let you go. What if I wanted to multiply 5 plus 6i and 3 minus 2i? And the answer is, I just realized that you can't see what I just wrote. Boom! Sorry about that. There it is. There's my subtraction problem. Should have paid attention to what I was doing. I'm really sorry. Got it all figured out now, though. Anywho, so this multiplication one, just like the polynomials, I'm going to use the box method. We talked about this in class a little bit when we were converting, or we talked about it in the converting notes, right? When you're converting from vertex form to standard form, you have to expand the binomial, which is a binomial times a binomial, which is what this is. So I have 5 and 6i, and then I have 3 and negative 2i. So let's multiply. 5 times 3 is 15. 5 times negative 2i is negative 10i. 6i times 3 is 18i. And 6i times negative 2i would be negative 12i squared. So let me write this out. I have 15 minus 10i plus 18i minus 12i squared. And that feels a lot like the polynomials we work with, but we can do something with this number that you can't do with just a regular polynomial. Now, I know you guys are itching to put negative 10i and 18i together. That's fine. So we got 15, and negative 10i plus positive 18i is 8i. This is where the fun comes. I squared, if you remember, I said was negative 1. That means that this is really negative 12 times negative 1. Which means we actually have 15 plus 8i. Look at negative 12 times negative 1 is plus 12. And oh my goodness, that means I can put the 15 and the 12 together. So I get 27 plus 8i. That is how you multiply. Most people will get these pieces right here, but they will forget that the I squared can be changed into just a number, and that can be multiplied back in. Whenever you are adding, subtracting, or multiplying complex numbers, you will always start with stuff that has two terms in each piece, and when you end, it should have exactly two terms. No more, no less, unless for some reason one of the coefficients is 0. Then you would have one term, or none possibly. Now, why is all this important? Well, in a couple days, we're going to solve quadratic equations using the quadratic formula. And up until this point, you really only had positive answers. And if there was a negative number under the square root sign, you were told to just write no real roots. Well, this is why, because there are complex roots or complex answers. So we're going to use this to do a little solving. That'll make more sense then. Anyway, I will see you later.